Welcome to the Paulson Topic Series. Today we're talking about product development, and we're following an item all the way through from concept to finished product. Paulson Manufacturing employs all of the most modern methods for developing new products. We develop products both for our own product line and for others. And in the case of today, we're going to talk about a new cap bracket. This cap bracket is used to support a face shield that's used for industrial safety purposes. It would not really matter what product we're talking about because they more or less always follow the same steps. In this case, the product is developed for the Paulson product line, and so it was entirely conceived of and designed here. The product does involve a patent, and I'll be discussing some of the aspects associated with patents as we go through this. Paulson Manufacturing makes a broad line of industrial safety products, and in those products we make cap brackets that support the face shields that are used for industrial safety. These cap brackets are designed to be mounted to your head with a headband, and a face shield is attached to this cap bracket for protecting from, let's say grinding or sparks or flying fragments. We wanted to upgrade the product line, so the very first thing we do is we develop a set of sketches. These sketches are artistic concepts of the product that we're trying to develop. Usually artistic sketches occur after a person has already envisioned what the product will look like, and you're trying to quote-unquote get it down on paper. Well, there's a lot more to getting it down on paper than just simply the sketch of the product itself. I'm now going to show you the rapid prototyping machine. This is also called additive manufacturing. It goes by more than one name, which is not unusual when things are in a rapid development phase in industry. The rapid prototype machine is a Fortis 360 MC. This machine has a build area of 14 inches by 14 inches by 16 inches. If we want to make parts that are larger than that, the software automatically cut the part and we'll be able to make it in sections and then glue it together. For most of our products, the build area is large enough. This machine is a state-of-the-art machine. It's using polycarbonate as the build material because that's very close to what we would use for the final product. Fernando has just printed a product in here. I think it had about a 7-hour build time, so we generally will do that overnight. The parts are very hot inside because this material has to be kept very dry, so the heat keeps the moisture from becoming involved with the material. Fernando, if you could take that out. Again, this was all unattended as it was building the product. In this case, it was building one item, but we can build as many parts and as many different kind of parts as we want on that same build area. So we could have built 3 or 4 of these at the same time. I can really feel the heat coming out of the machine. So Fernando's holding the part. We built it on this thin film of plastic, and this thin film of plastic, boy, that AB is hot, shows the part as it's been built onto the material. There is a supporting structure, this brown material that you can see here. That supporting structure needs to be there to support the white material as it's being formed. It's all done layer by layer. So think of it like a giant layer cake. Layer by layer, the plastic is deposited across the surface of this plastic and built up. This base material here will be removed either by breaking away or by dissolving it in a lye solution in an ultrasonic tank, leaving just the final product that's what we were trying to make. The part is very accurate. The size of the part is accurate to within about 10,000ths of an inch across a part this size. So we're able to do our designs exactly to size, to check the fits. We can even take these parts and take them to the test lab and do our impact testing or other types of tests on this item. Once the part is designed, then we have to make a tooling design. This is an example of the tooling design when it's in 3D CAD. So as we're looking at this picture, you can see the part is oriented right here. In this case, there's two of them because for efficiency, we want to build two at once. This shows the mold base. This shows the ejector box. And all of this lists down the side here are all the different levels that would show the parts. It includes the water lines, the cooling, the ejection for the system. And this is only one half of the mold that's showing. The other half is not in this particular view. The concept, though, is that once the part is complete, you have to go into building a complete mold design before you can start building the mold itself. This requires specialized training, both in CAD, understanding of thermodynamics, understanding of melt flows, of how the materials will move into the part, and how the parts will eject. There's many different aspects to this. In the process of mold building, we have to take the mold designs and create the product in steel, aluminum, so forth. The molds create the surfaces that the plastic will be injected into. So as you can see on this machine, we're installing water lines at this time. The water lines are being drilled down through this block. Over here, my shoulder here, you can see all of the commands going across for this operation. It's one of many, many steps in the mold building process. This particular machine is a vertical machining center. We'll show some of the other machines that are used, but there's vertical machining centers, there's a wire EDM, sinker EDM, surface grinding, very many steps that are involved with building all of the tooling associated with our products. These are the mold bases that are used. The inserts will be placed inside these steel mold bases. So it's actually, the inserts in this area will be actually making the part. You can see all of the intricacy of the machining associated with these mold bases. All of these plates and assemblies here in the back will be all attached to this mold base to create all of the actions that are necessary. This is somewhat like the engine in your car. It's very complicated when you take it apart, but when you're using it, you don't particularly think about it. So this is how the part would be removed from the mold itself. This is two sides of the mold here as you're looking at it. The part is formed in between, and these two surfaces close together with a pressure of 300 tons. Out comes a plastic molded part that's made directly from the resin granules. Then the cycle would repeat. We get about one part every minute. So this is where the tooling that you saw us making in the machine shop would be installed. And everything from here to here is the tooling section or the mold. This is high-speed graphite machining. So in this high-speed graphite machining on this Roku machine, we're actually creating electrodes that will be then burned down directly into the steel. This is about as accurate as you can have of a machining process, and also the highest technology method for machining steel and making the final products. This is the end result of this type of machining. The end result is graphite that's been machined very precisely into a positive. This positive will be electrically discharge machined down into the steel, creating a negative of whatever is on this block. This is an example of a part cut by wire EDM. In the wire EDM, it's cut with a fine wire, and you can see how this side has all been cut in this particular shape, but as I turn this over, it's a completely different shape. This is solid steel, it's been cut with a fine wire, and it's exactly what we use for machining by that process for many of the detailed components in our injection molds. This is our vertical machining center made by Morisiki. The NVX 5080 is our most accurate machining center for large steel blocks. We do our optical parts on this machine, and we're able to go almost directly from machine surfaces to optical finishes. The tooling that we're showing was also cut in this machine, and you'll see the finished product at the end of this. In our product development to build this new cap bracket, we've now brought it to the point that we have the injection mold built. This is the actual injection mold that's making the product. This would be considered to be the hot side, and this is called the cold side. This is also called the cavity, and this is the core. These molds are all made out of hardened tool steel. You can see the insert lines here where we've inserted the hardened tool steel into the mold base. These sections right here are lifting spring-loaded sections that make sure that the part is pushed off of the hot side. On this side here you can see the runners. That's this section right here where the plastic comes in through the sprue, moves through the runner and goes to the gate. So the sprue is here, the runner, the gate, and it flows into the part. You can see how the part fits right into this space right here. Obviously it's making two parts at once. The plastic goes in and flows all the way out to these two ends. Completely fills the part, cools, and then it ejects off of here. The ejection, you can see the lines where these hardened inserts are here. That all moves forward and lifts the part off of the mold that way. Otherwise the part would be trapped, especially since there's all of this complex detail and fine, thin wall sections that are way down deep into the part. It would be trapped on there. So that pushes it off and allows the operator to remove it from the tool. You're looking at Class A tooling designed to run for over 1 million parts. Now that all the tooling has been completed, we go into what we call a trial run, sometimes also called a first article. The first article is when we'll set up the mold for the first time and make our very first parts out of that tool. As we had shown earlier, we decided to make a 2-cavity mold for this, so it makes 2 identical parts for every press cycle. Every cycle of the machine is about 45 seconds, and this particular part will then have a second operation of trimming off of the gate and installing holes here on the side. You can see here, this is the first part off of the mold as we described it as the first article. There remains some polishing that needs to be done on here, which will put some polished areas on this mold, and also what remains is the logo, which will be actually a second operation. Pad printing will be across the top. All of that was in the original design and the original sketches. You've been through our mold shop showing parts being manufactured in the mold shop, so you now have a concept of what those look like. You saw the mold opened up with the 2 cavities, showing the sprue and the runner system that feeds the plastic in, the ejector system that pushes it out of the mold. So as you can see, product development is a lot more than just developing the product.